Okay, folks, let's keep going. Somebody want to share what they were able to get done last week?
Unfortunately, I still haven't managed to make a submission, but yeah, I spent the entire week slicing up spectrograms and rearranging windows and stuff, but I haven't got as far as actually training anything yet. It's like taking me an entire week to just look at the slices or whatever. So I'm still working on it.
Okay, Steve, anybody else on any progress?
I can update some of my part. It's not big. Let me share. Let me know, can you see the screen? So essentially, this week I did two things. The first thing is I try to speed up the timeline. So it's a notebook I sent before. It's about pre-computing the spectrogram and then load them in to speed up the training loop. So I think the speed up is pretty significant. So you can see this for comparison, like before I speed up, when I train the true positive and false positive together, it takes something like 4.5 hours. It's pretty long. And then after I do the speed up, it only takes 35 minutes around to complete the training. So, and then it doesn't sacrifice much on the performance. So you can see performance is pretty much similar. So I would say it's pretty good. So that's the first thing. Another is essentially this week I mainly do a lot of ensampling and see how well I can go by simply doing the ensample. And the conclusion is ensample is pretty powerful. So what I do is, so you see here is the 5-fold submission. Sorry, so it's a 5-fold submission when I train on the true positive and false positive using the mask binary cost entropy loss, essentially training 30 epoch. So that's a 5-fold result. And then what I do is I try to ensample them. So from that, you can see there's a 2 to 1 point performance gain. In this case, compared to the ensample by rank, it's better to do ensample by rank in this case. It's not the point that. And then after that, I go back to the original baseline I have. The original baseline is I only train on true positive and also train for 30 epoch. So what I essentially do is I also do a 5-fold training and 5-fold submission. So you see the public LB score varies quite a lot. And then based on this 5-fold model, I do an average ensample again, and also the rank ensample again. So you can see in this case, the average ensample did slightly better, but I'm not sure whether it's significant, but also it's not the point. But eventually, so here you see, I finally, I think it's not here. Where is it? Wait. Yeah, here. So here, what I essentially do is I have a ensample of 5-fold model, which is trained on true positive and false positive. This one. On the other hand, I have a 5-fold model that is trained on true positive only. And then I do a ensample on these 10 models, because eventually I have 5-fold plus 5-fold, so I have 10 models. So I just do an average ensample on this 10 model. At the end, I get eventually surpass the 0.9 LB score. And then I try to compare with the rank example again. I would say not much different. So today what I do is so interestingly, yesterday, there's a Grandmaster panel, which is hosted in YouTube. I'm not sure you guys have heard of it. Essentially, 4 Grandmasters share their tips and tricks on Kaggle competition. So one of the Grandmasters I remember is Chris. So they share one simple trick. Essentially, by the time you train on the 5-fold model, right? What you usually do is, let's say you have 5-fold. Each model will be trained on the 80% of training as a training set, and the rest as a validation set. So each model will be trained on 80% of data set. But what he do is, in your final submission, you use the same configuration to train the model on all the data sets. And what you change is only change the random seed. So you have 5 models, which is trained on the full data set. And then you just change them by the random seed. And then you try to do an ensemble over that. So I just want to simply experiment that. So that's what I did. This is the result that I do on the 5 random seed result. So I won't say it's 5-fold because they're only different by the random seed. So compare with the model that is trained on the 80% data set, I would say actually there's not much difference. Where is the result for 8-fold, 5-fold? Yeah, I think it's this one. I would say if you look across these, like if you train on the 80% data set, it looks to have a higher variance compared to this, right? This is trained on all the data sets. Oh, it's not. Which one? Yeah, I think it's this one. So you see, I think in this case, the variance is less. And then after that, based on these 5 models, which is trained on different random seed, I do an average example. So similarly, it will get a 2 to 1 point boost. And then in this case, also in this case, the rank example did better. And then I do the same thing again on the model that's trained on true positive. And then what I do is I have all these 10 models, right? I try out the overall example again. Where is the overall example? Yeah, I think this is the overall example. It's also surpassed roughly, so lightly speaking is roughly surpassed 0.9, but I would say there's not much difference. So yeah, that's pretty much what I did. So I would say the trick Chris shared did not do quite well in this case. It did not give much performance gain. But I would say, nonetheless, ensemble is a pretty powerful thing. Overall, it can give you 1 to 2 points, or you can have 5 points of performance gain. So my hypothesis is that whenever I notice the model have a high variance over fold or a high variance over random seed, I will hypothesize that this is the place where ensemble could shine, because it notifies that the model is actually learning different things, and it is reflected by the variance in the LB score. So I think that's pretty much it. On the meanwhile, I'm trying to code up the pseudo label, but it's running pretty slow. So I'm still generating the predictions and get out the pseudo label. So I think probably I need next week to get this done and see whether there's a performance gain. So to me, my goal is to get a 0.95 LB score. So I think right now the progress is okay. I finally get past the 0.9 is a good milestone. But the 0.3, I will expect the rest of the point is harder to get from 0.9 to 0.93, I mean. So I guess pseudo labeling can help. So let's see. Do you have any questions? Otherwise, I will close my screen.
Nope, thanks. Yep, as I previously showed as well, I think in this case, the ensembles, they do improve, but I think, you know, the specific fixes that you had shown, I think earlier, and I saw as well of adjusting for particular classes, that seems to have, in this instance, almost as big, if not a bigger impact on the scores from my results. That is, if you adjust for a couple of classes which are low representation, those seem to make a bigger difference than.
Oh, you mean you do some
ensemble.
oversampling? You mean you do some oversampling
Yeah,
on the
or
rare class?
basically,
Okay.
you know, things like you had done adjustment, I believe earlier you had shown, and that, at least in my experience in this competition, that seemed to give a bigger boost to the score than ensemble. And of course, if you, I mean, ensemble, like what you said, which is very different models, then definitely that has a significant impact. And I think, as is probably, you know, unfortunately, in some sense, for all models, in Kaggle, the ensembles seem to eventually end up winning, which is the reason, at least, that I try to find out a single model or the thing which does really well, and or different approaches that individually seem to do reasonably well, and then combine them, as you mentioned. That definitely results in a much better ensemble score.
Yeah, I believe like the fact that I'm mixing two completely different models, a model that is trained on different data set, is the reason why they have such a performance gain by the time I do an ensemble. Oh, one more thing is like you mentioned something we can do is oversampling the rare class, or you do some penalty on the loss, something like that, in order to emphasize the rare class, right? So I did something similar this week. Essentially, because what I noticed is that by the time I mix training true positive with false positive, the validation loss fluctuate a lot. So my hypothesis is that it doesn't have enough of positive labels to learn. So I guess is struggle on the true positive, because compared to true positive, the false positive is something like 7 times or 8 times bigger than the true positive. So what I essentially do is I try to balance out true positive and false positive, essentially make it as 50-50. So it's something like a weighted, how to say, essentially I just add a sampler so that they balance out. But the result didn't went out pretty well. I would say it's worse. So I just give up the idea.
Actually, that, you know, what you've done seems to be, so since we've been at it for almost, I don't know, maybe 4 or 5 months, I'll share, you know, typically look at it towards like when waiting for Steve to make a submission, but maybe I'll share it in this week. I kind of compiled some of the overall submissions into a table that I'll subsequently post a link to. But let me share that, if I might, let me see where it's at. I believe this is this one. Let me see. No, not that. Just give me a minute. There. Okay. Just a sec. Okay, can you folks see my screen?
Yep.
Yep.
Okay, so this is just a compilation of the, like some of the approaches that I could, and and eventually some of the top ranked contribution, but also some of the other ones just to get a flavor for a lot of them. So what I did was just put them together, and you can kind of, as I said, I'll post this table later today on Slack, but just going through it because some of it is related to what you're mentioning, Alex, and some of it is general learning. Unfortunately, in this case, or in the case of this competition, maybe because there's also another similar one, there aren't too many, code examples that you can stare at to maybe even go through in detail later. But what I did is just post their rank. The score, I kind of didn't double check whether these scores mentioned, some of them have resubmitted after when they wrote their descriptions and stuff. So this score may not be exactly precise. You can find out more. I gave you the link if you need to go and check and read for yourself, because obviously it's just a summary. And then I mentioned whether there is code is available or not. And then just some comments that I thought were somewhat relevant. Not all of it is very detailed. Sometimes I skipped it. Can't tell you exactly why I did that, but maybe I was just lazy, but some relevant comments to how they approached it. So that can at least give you a flavor of what worked and what didn't, and what were the variety of approaches that people used to get an idea of, what seems to work really well. And what you see is, at least in this competition, it seems like there's, much more variety in the approaches that people have taken to gain the ranking and everything, and you can see even 75th rank is about where, Alex is right now, and about in the 0.90 type of range. This is the SCD model, but with changes to the parameters that the model actually, that the default, and this is sound effect detection or something like that with a generic sound oriented model that's published in relevant paper. And then this one is, just high resolution spectrogram. I think this particular 38 one, sorry, I forgot to mention one of the things this particular thing talks about, and it's used in multiple, if I recall, examples. Among the top results is this whole teacher-student type of approach, which also does, it's along the way direction that Alex is pursuing of pseudo labeling. On that note, though, if anybody has a good reference for teacher-student example paper with code, that would be something I think it would be great for us as one of the next sessions to kind of either go through the paper and the relevant code as a learning from this competition, because I think teacher-student approaches are common for this particular problem, and also I've seen it become more commonly used in other things. But I'm still trying to locate a good paper. There's knowledge distillation, but I haven't yet found a good paper with code that we can go through. So if anybody has that and would like to take us through it, I'd really welcome that. But if you even have a paper reference, maybe I'll look at it and see whether I can do that. But if you are able to locate it and take us through it, that'd be really great. That's an important concept that I think we would benefit from learning from this competition. Moving on, there's a Tpu implementation, and this masked loss that Alex has also mentioned, masked binary cross-interpret loss, and there's kind of approaches. This I have not spent time on looking at, how cut mix is different, and if anybody else has an idea of explaining the difference of cut mix, that would be great. We can look at that as well. Moving on, by the way, this particular notebook has TensorFlow Code and TPU utilization as well. So I think if you are TensorFlow oriented, this would be a good notebook to kind of dive into and look at. I didn't spend any time on it because I was focused on PyTorch implementation. Then somewhere in the 30s and 20s, there is a threefold efficient net, and some of the other. This particular one uses a whole variety of different types of losses that I recall. So that's something I found interesting. I haven't had the time to look at the details of the various losses, but they use all kinds of different losses that I thought were quite interesting and different from what everybody else had done. Let's see. This particular one is something that I was trying over the last week to get working. It's a FastAI based solution. And again, he's gotten pretty good mid 0.95 range. And what attracted me to this solution was, while eventually he does a little bit of ensembling, but again, it's just of the folds. And at least to me, the attractiveness was that he was using FastAI and also uses a variation on a theme that I was trying as well, which is just to try different crops and different dimensional crops and combine them. And that's where I was trying it. But what is interesting is even with as little as a month or maybe 3-4 months having gone by, there are issues with the code and the code doesn't quite work as is. So I'm trying to see what the problems are and debug that and see whether I can get it to work. So that's something I spent quite a bit of time on. And this is one of the reasons I was generating the audio, because the other thing which I was interested in, because most other things do a spectrogram based, and this is based on audio, on raw audio and augmenting it in the audio space, which I thought was another reason to try this approach. It's FastAI based, which at least I understand the code is PyTorch based, and then it does an approach which is similar to what I've tried, blah blah blah. But so far it doesn't work, or at least there are issues with the code and the models and stuff like that. So I'm trying to resolve that. Then there's the contrastive learning. This was something else I meant to try, but I will see whether within the next week or so I can do it, because this is relevant to this whole energy-based kind of approach, which is relevant to contrastive learning, right? So it's the utilization of FPTP and contrasting that. Now, beginning here, and you'll see, this is another thing which in this particular competition, many of the winners towards the end, you'll see a lot more of is they've used a lot of extra labeling or extra data. And extra labeling means, they either do the pseudo labeling stuff, or in some cases, as we'll see subsequently, they've even done manual labeling of what they believe is are the missed labels in the true positives. Then there is this which is, I believe, rank of 21. I forget what the, I couldn't easily find what that resulting score is. And then there is utilization of the false positive. And there are many more ideas in this as well. Many of the others in this range don't quite share the code. As you can see, there is an ensemble. Again, this is the cropped frequency versus time. This is again the teacher-student type of approach to get to the 0.94 score. So many of the 0.94 level of things have all taken this kind of approach. Moving on to kind of the top 10 results. One of the things which is very interesting, and again, as I mentioned, I've been trying to stick to, other than the k-fold, not doing any more additional ensemble. Just I tried that several weeks back, and then I wanted to kind of improve the base model or models on which eventually I would try the ensembling. But if you look at this particular post, it gives you an approach that is, or a post-processing approach that apparently is applicable to almost any model that you come up with, because it's you're post-processing the results that the model generates. And I haven't gone through it, as I mentioned, I wanted to get the best result from a single or a fold ensemble, and then try with these kind of post-processing techniques to improve that. But this author, I mean, obviously he has a base model, but he specifically provides code for how to post-process using that. And many of the winners, some of them even have gone back and applied this post-processing technique, and I believe it's based on the data even from the original paper, which provides the source data for our competition. And then, these approaches, you can begin to see, 15 models. Some of the things down here are like 90 models that are ensembled, and so on and so forth. And then you can see what I mentioned, there's like manual training samples are added, 80 models. The other interesting thing here that I saw for this particular submission is also this I thought was an interesting approach or technique, which is to use, since the channels, in our case, when we use a spectrogram, we use the same data in all three channels, right? Whereas what these guys have done is use different NMLs and different FFT and provided it as input to each of the different channels. That I thought was an interesting variation on just providing the same data of the spectrogram to every channel. That's kind of an interesting variation. This one, again, an interesting variation is they talk about besides the variety of things, the two things I thought were interesting is the fact that, something even I missed, and many of the others which have gotten even up to 0.95 score didn't quite account for this, which is that a couple of the classes actually have multiple songs. So technically speaking, we would need not 24, but 26 to cover the case of those songs. That is, one species has two species have two different songs. So you'll need a 25th and a 26th class to cover that. The other thing that these guys do, which is I thought was also interesting, maybe a simple thing to try, is not use a MEL spectrogram, because if you think about it, there is some argument to be made, although I don't know whether if we try it, whether we'll see the results they see. As with all machine learning things, it's fair to say your results will vary depending on what network you use, what set of parameters, other parameters, and a bunch of other things like that. But their claim is hey, the MEL spectrogram is only relevant for human hearing, so there's no reason to convert a spectrogram to a MEL spectrogram and then apply the learning techniques. It's okay to just go with no MELs case at all. So that's interesting. That is, you just use the base spectrogram and not a MEL spectrogram. You use the two, use the mass focal loss, and then they do something called a mixover, which again I don't quite understand. And you can see, Alex, that a lot of the winners end up using pseudo labeling. So that's why I think the path you're on for pseudo labeling ought to give you better results. But then again, as I said, mileage may vary depending on what else you're doing. But it definitely seems to be the right track. This is the highest ranked notebook that also has PyTorch code if you're interested. The thing though is it uses a data set that's stored. I don't recall whether the data set is still available. Sometimes people tend to delete generated data sets. It uses a multi-stage approach with 3 stages, and the first stage is does a certain set of things, then the second stage uses pseudo labeling, and then generates like labels of +1, -1 for TP and FP, uses a specialized loss function, and then a sliding window, and then the third stage uses something from the second stage and a variation of mix-up. So, there's a lot more detail obviously at the link that you can go look at, but that's kind of the basic approach. And you can see that they've kind of reached the 0.95, 949, and at least I think they provide links to the code. Then the top 3 or 4 things here, again, it's a 3-stage using semantic segmentation, which I thought was a interesting variation just in the 3rd stage. The last 3, report of many ideas tested. So I think you need to go to the link to see what are all the different ideas. But on the other hand, much like Alex said, reported so far the second guy says pseudo labeling. In this case, they report that they continue to use pseudo labeling until the score starts improving. I should change there's a typo there. And then it's a 4-fold 4 model, and then they use something called a RexNet that I haven't seen before. I have to look at what that is and how that's different from just a ResNet or a ResNest. And FNet, and I think they use ensemble of these 2 types of model. And then the final one is a huge blend of 120 different models, and the weak, which is with no specific time or frequency orientation, just that particular label exists in the recording level, that is for the entire 60 seconds, and then a hard chunk level labels, and then combination of that. And I don't recall whether it's again a multi-stage model or just a single stage one, but it is a multi-stage, at least insofar as they use a blending method to combine different models, 120 different models. So that's, if you will, just something that I wanted to get a flavor for the variety of techniques that I used. And I usually wait until at least everybody has reached a certain base level, so we are kind of close to about getting to 0.9-ish. So these are the techniques that people have used to get beyond 0.9 and into the range of 0.95 or to 0.9. Obviously the last guys are in the 0.9899 range, I think.
Speaking about the co-teacher, I actually find out a notebook. We try to demo how to use the co-teacher, and it's also applying on this competition. So I already posted in the Kaggle, in the Slack channel, so you can check it out. And then for the
and actually, I mean, once we are done what I typically like to do, I mean, we probably have a couple more weeks to make a few more submissions, see whether we can, like you said, get to the 0.9495. Then let's spend a week or two on going through a paper or a demo like that, and kind of step by step. So at least we take away a lot more than just, if we obviously can grasp it from Slack, that's great. But if not, let's kind of spend the time on it.
Yeah, and about the cut mix, right? I think the difference is that for the, so you mean, you know, in the mix-up, what it actually, how it actually works is that you try to do some interpolation between two samples, and you try to interpolate on the whole image. But for the cut mix, essentially you randomly crop a region, and you randomly crop a region on one sample, and then you try to blind it out. And what you do is you replace this blinded region by the same cropped region of the another sample. So essentially you will have, yeah, so essentially it's something like you have, if you cut mix a cat with a dog, something will happen is that you will crop out the head of the dog, and then you replace it by the head of a cat, if they are standing on the same position, something like this. So I would say there are many differences is only on, I would say in the mix-up, you try to mix two samples in a soft way, but for the cut mix, it's a hard way.
But the
And
net
also,
result is that basically,
yeah, go ahead.
The net effect in both cases is to kind of reduce the confidence level of the network's predictions and make it softer in that sense. Is that right? Or is the goal
I would say,
of the two?
so because for the mix-up, right, it will do some adjustment on the target variable by the time you try to do mix-up. Because let's say you try to add 50% of cat to 50% of dog, so definitely you need to apply the same change on the target variable. But for the cut mix, I'm not sure. I need to find out the details of that. I'm not sure whether they do any weight on that. But I think the gist of mix up and the cut mix is essentially try to create more training samples. Personally, I think that in this case, right, I think cut mix is more appropriate because in our case, each audio have its responsible region, right? We know which crop region is responsible for the species. So knowing this is pretty useful to generate a lot of cut mix sample, like, because you can imagine we can crop every region, we can crop every region that is responsible by each species, right? And then we can just randomly paste them into the background audio, so that we can generate infinite amounts of the samples. And not just that, for the mix-up, right? Usually you mix two samples. But if you can do cut mix in the competition, I think you can cut mix multiple samples together. Essentially, you just paste species 1, species 2, species 3 all together into one background audio, and boom, you can get a sample with a lot of species. So I think this is something
also
pretty specific to the competition.
Interesting. But also I was thinking if that's, meaning based on what you described of cut mix, it would also be interesting if, for example, using your pseudo labeling, if you, for example, can identify where the non-labeled audio is, then potentially you could drop in cut mix of that species in that location, right?
So if you know which place is a background, right? you can paste a lot of speeches on that and create a positive sample. I think there's something fun that I would like to try later on, but I don't have time. And I guess coding up this solution, I mean coding up this technique will take time. Because you need to keep track of the metadata in your tensor, and by the time you collate them together, you need to I can at least I can foresee there's some nuance by the time I implement this solution like this. But I think it's a pretty interesting idea. It's a good way to generate a lot of sample, and I would say the sample it generates is pretty high quality. But I can see there's some nuance here, because when you blend in the crop species region into the background, right? You can see there's some bumpy region, I mean around the edge. I'm not sure whether it will impact the sample quality. I'm not sure we can smooth out this kind of noise or bumpy region by some audio processing technique. But I can foresee there's some issue that I need to address in order to get this technique shipped into my training pipeline. But yeah, essentially just some idea pop up in my mind about the cut mix. Because something interesting about audio is that you can superimpose two audio and they will sound pretty natural, right? I'm not sure whether it's the same if we do that in the spectrogram. Actually, what I do is quite different from superimposition, because essentially I just do a copy and paste. Well, I'm not sure. Really need to try it out if I have time. And also for the pseudo labeling, right? For pseudo labeling, I can foresee there's a lot of nuances. For example, how do you filter out the pseudo label? How do you group them together? And what kind of model do you use to generate the pseudo label? So because I can see some people use single model, some people use out of fold, some people use example of model to generate the pseudo label. And also whether you should apply some soft penalty on the pseudo label. Yeah, I can see there's a lot of detail, and I didn't see a demo notebook in this competition that is related to pseudo label. Yeah, so I will foresee this in the upcoming week. I probably still will struggle on the pseudo labeling thing to get the details right. And yeah, co-teacher is also something I'm interested in. But one thing I'm curious is how much performance gain you can get compared to a naive pseudo labeling approach. That's my question, right? It sounds promising, but I would doubt whether this state of the art can get a significant boost compared with the naive model. I mean, a naive approach like pseudo labeling.
Yeah, I mean, actually, if you see, that's one of the reasons, after we have made some submissions, I try to do this after a while to get some idea of exactly what you said, which is how much is it just that, oh, it's a different approach versus how much is it foundational to getting a really good score. And that's where if you see, guys, and actually, since I've worked with it somewhat, this particular thing, he is using a very, what I consider to be a fairly simple approach to a base model. Yes, it's an ensemble of different.
I recall I saw it before. It's pretty clean. It's pretty clean.
Yeah, it's not that complicated, and it doesn't do a lot of what other people do, and it's still a very good score in the 0.94 kind of range. And yeah, I mean, of course, if you do 80, 100 models and you ensemble, you can probably get to 0.9798. But at the same time, this, for the simplicity and straightforwardness of the approach, it seemed really a very good result with a fairly simple approach. But that said, I still wanted to do the co approaches of pseudo labeling. He doesn't use pseudo labeling either in this case. Neither does, to my knowledge, this guy. So they've achieved reasonably good score without doing co-teaching or pseudo labeling. But I also wanted to pick up those techniques because if not here, maybe in some other competition, it would be kind of foundational to getting a good score. So that's more. Here it seems like it is possible to get to the 0.9495 range with fairly straightforward approaches, well implemented. So.
Yeah, I look at it first. I look at the first winner solution before. Like it's so convoluted, have a lot of models. So it's also, at least if I'm in competition, it's not something I can do. Right. So in comparison, the solution you raise is pretty. Yeah, I also tends to favor those kind of clean solution. Those solution looks pretty effective. You don't need much example, but to me, I also want to see the power of example, because you have a clean solution, a single model that can give a pretty good result. You can also think about how to ensample this clean solution with the baseline that you have or the other models that you have developed. When you have a different diversified model, I think it's pretty powerful to apply the ensemble. Just some of my thoughts. And also, what else? Yeah, for the mean co-teacher, I think there's quite different approach to this kind of technique. I guess this kind of technique is something called semi-supervised learning. I'm not sure. Essentially, it's a case where you have some noisy data set or unlabeled data set, how to deal with that. Another model that's related to this technique is called noisy student. I'm not sure the difference. But I think by the time we go through this, probably we need to go through both, like on the mean co-teacher and also the noisy student. Are they the same thing? I'm not sure. I guess teacher and student in pair.
Yes, teacher-student. In fact, the technique often is referred to as teacher-student, and when I looked at it, it's also referred to as, in some case, and that's why I wanted to dive into a little bit if there is a good paper on it and stuff that with implementation. The reason I say that is these are all somewhat related, but it's not extremely precisely defined as far as I can see, because the teacher-student approaches, again, they are more broadly also referred to as knowledge distillation. And if used as knowledge distillation, then it seems the goal of knowledge distillation is, in fact, to take initially a fairly complex model and then quote, that's where the distillation comes from, and then generate a far simpler model with a large reduction in the number of parameters used, which is almost as good as your much more complicated, much heavier model. And that is referred to as knowledge distillation. And if you ask me, for example, how is knowledge distillation, which refers to teacher-student or teacher-student, different from the co-teacher and noisy students, I can't tell you. So that's kind of what I'm interested in that, understanding those details and really figuring out which of these techniques or how is teacher-student generic enough to where it applies in all noisy cases, or it is just a case of applying it to extract knowledge and from the more complex model and teach a student, which would then make the student model have a lot less parameters, but almost give as good results as your teacher. Or is it used for more than that, and are these just variants? So these are all questions in my head, and I haven't gotten good answers to that from, at least, and I haven't done too much research, but just poking around, I haven't found resources which kind of explain the answers to all these questions. So if anybody knows and has references, please post them or speak up.
I think it would be good to have one or half a session going through this kind of technique.
Yeah.
At least you can clarify our
That's
confusion.
something. Yep, exactly. That's what I'm kind of looking to do. Okay, so I think that's kind of what I did besides trying to get the, this particular technique to work. And I ran into some trouble with some errors that being reported, but
oh, by the way, you mentioned you try to use Fast AI framework.
Yeah, that's this particular, based on this particular approach that the guy has implemented. So I don't exactly, I just took pieces of his code and I'm stitching it together because he has a very broad generic approach, and I'm just saying, I don't want all that fanciness. Let me just do what I need to do. But his code is based on Fast AI. So this thing is Fast AI based. This, sorry, am I pointing to the right thing or the wrong stuff?
Is it row 7?
Oh, sorry, that guy, 27th rank, about 0.93, 0.94 private. And you can find it.
So in the solution, he mentioned he do crop around the positive sample. Do we crop only on the time interval or also crop in the time plus frequency interval?
Sorry, could you repeat?
So you see that he mentioned that he would do a crop around positive samples, right? In the comments you wrote.
Yes.
I just wonder, do he crop on time interval, or do he crop on both the time interval and the frequency interval?
I don't believe he crops on the frequency stuff, right? He just, crop meaning he just does the, if I recall, the min max, or I don't even recall whether he does that. It's basically the time interval. But the difference in this case, and this is the puzzle which actually led me to also this, there are multiple reasons why I focused on this particular implementation. One, Fast AI. Second, it's fairly simple, as you also mentioned. The third thing which intrigued me was my base implementation that I've worked with quite a bit and tweaked it to get to about 0.89 level of results. Utilizes a very similar approach, except it works on the spectrograms. In this case, the guy works in the audio domain, that is in the waveform, NumPy waveform domain. Obviously, he converts it to, and does the augmentation in that domain before he takes it to the MEL spectrogram type of stuff. And the thing is that even in this case, what he does eventually is he kind of tries this and if you look at his code, you'll see that he does this thing where he's predicting on slices of or images of different dimensions than the dimensions that he trains on, right? And so that's very similar to what I had tried, which is take let's say a 5-second or a 3-second or a 6-second crop and try to predict on 6-second itself, but then also maybe 7 and 8, or if you take a 5-second crop, then predict on a 6-second crop and a 10-second crop, and then try to ensemble those and stuff. And actually that didn't give me all that great result. I mean, I was still, as you saw, hovering very close to 0.9, but not on the other side without ensembling. I mean, I got there with ensembling, but without. In this case, the guy is able to get much farther down the path. So that's what intrigued me, because the approaches that I was taking and what he's doing seemed very similar, except that he was first augmenting in the audio domain. And I was like, really, is that causing that much difference? And maybe it is. As with many things in machine learning, it's impossible to say what the difference will be until you try it. So that's why I was pursuing this, to say, wow, if that is the case, then it definitely says, there is that you ought to, for such problems, try to do things like augmenting just in the sound domain and then taking it to spectrogram, if indeed it causes this much of a difference in results. Because my current approach is mainly augmenting after you in the image space, right? Not in the sound domain, but in the image domain after converting to spectrogram. But here he augments in the audio space and then converts to spectrogram and then predicts. So that curiosity drove me to this example as well.
Is it the only difference you found between his solution and your solution?
The other variation is he does resampling at 32K. I did try it in my case as well, meaning I resampled. If I recall, I did it though at 36. I'm not 100% sure. I have to go back and check. But I did. That's another difference. He does a resampling at 32K, and in fact, that's where I spent a week. And thanks to Steve's help, I was eventually able to get that thing working to where I generated the audio files, and the audio files are so huge compared to the image files that I had to store them in multiple data sets, and then I combine it when I'm ready. So that's another difference. But I did try the resampling at least. But again, remember, resample and then immediately take it to the image domain. And just resampling, changing from 48 to 36 or 32 even, didn't actually make a big difference. And it makes sense to resample to 32. I mean, I can get why it does that, because if you look at the max frequency, it's less than 16K in any of our samples. So you don't really lose anything in the frequency domain when you go to a 32K resample, versus our base is like 48K. So you're just getting a lot of Y dimension in spectrogram wasted by going to a 48, because your max frequency of any relevant sound is only 15 point something K. So anything on top of, because 48K will give you up to 24K. So unless you chop the 24K down to like 16K, you leave a lot of wasted pixels in the Y dimension, unless you go to 32K, right? Because that it improves your resolution. How many pixels you devote to the relevant frequencies that you're trying to capture is a lot more wasted when you're at 48K, which is your base sample. But it's a big deal because it takes a lot more time when you have to resample. So that's why it also makes sense to do what you did, which is, or to see what you saw, what you showed today, which is the speed is tremendously improved if you generate the MEL spectrogram offline and then use them.
Yeah, I would say the audio space augmentation seems pretty important. But meanwhile, if you do a pre-computed spectrogram, partially you will sacrifice them, but there's a way to remedy it. I think, sorry. In the notebook that I post, I have a way to remedy it. Essentially, I just save different snapshot of the same audio. So in this way, you can increase the variation. But meanwhile, you're sacrificing the disk space. The more variation you want to introduce, you need to save the you need to save way more samples. there's a way to remedy it, but I would say, do you say
Sorry,
something?
question. What do you mean by variation?
So essentially, supposedly I will have one file for one sample, right? So what I do is that I will have multiple snapshots for one sample. So essentially, I just try to
I'll
resample the.
stop sharing if you'd like to share.
Wait. Essentially, it's a simple idea. In order to include the augmentation into the pre-computed file, what I do is I try to resample the same sample again and again with different augmentation and save them into different file. Let me see. So I think you understand if I show you the code. So you see, here is the loop, right? In the outer loop, I loop over the sample. In the inner loop, I try to resample the same sample again. In this way, each sample will have a slight difference, and they are caused by audio domain augmentation. In the above, I try to do the augmentation like this. So you see. So right now the augmentation I do is pretty simple. Essentially adding noise and resize and do some random crop. So that's the way I do it. In this case, I try to create 15 snapshots, 15 different snapshots for each sample. So this can take into account the variation of the mass spectrogram. So by the time I create the data loader, right? In the data loader, I try to randomly sample the snapshot. So you see, I do a random choice here. So in this way, I can kind of emulate the augmentation here. So you can check out the notebook if you want to see how you can do this thing. But I would say it could eat up quite a lot of this space. But if you're working on Kaggle notebook, then I think it's fine. But I would say the speed up is quite a lot. If you only train on the true positive, right? Originally, it takes around a minute to complete an epoch. But if I use the pre-computed file, it only takes something like 10 seconds to complete one epoch.
Yep, that's huge. 6x. Okay. Anybody else want to say anything? Okay. Quick question, folks. Next week is July 4th in the US. I might be traveling. Anybody else want to continue the stuff? You're welcome to. I might not be able to join. So let me know maybe in Slack whether you want to have the session or just cancel it and meet 2 weeks from today. And about that time, maybe when we meet 2 weeks from now, we'll probably try to have some final discussions and then dial in on the couple of papers or relevant techniques that we want to spend a session or two on. And about that time, I think, meaning 2 weeks from now would be a good time to also begin to think, not right now, but after we have that session and maybe one or at most 2 sessions of some paper discussion related to this competition or something, for example, relating to student-teacher learning and that kind of an approach, or even for that matter, the paper on REST nest and how that's different, or REX nest that we have seen. Anything else that people have suggestions on? The other thing to start thinking about towards the middle of July and the second half of July is what next competition should we begin to look at or think about. So just wanted to lay it out, and please chime in on Slack whether you want the session and would be participating. I might not be able to join. So at least my vote would be that we meet 2 weeks from today. But I, am open if others are wanting to meet next week.
I'm
I
happy
would
to meet in 2
prefer,
weeks.
yeah, I prefer to skip over next week if there's not much participant.
Yeah, I'd be the same. Yeah, like I've got a family thing on next weekend anyway, so I don't think I could make it anyway. So hopefully 2 weeks
Okay.
gives me enough time to get something submitted.
Okay, sounds good. So I'll just mention in Slack that we'll meet 2 weeks from today and kind of wrap up our final discussion and kind of tee up which particular papers, and if by chance you or anybody else, I'll also solicit any paper suggestions to look at related to this competition over maybe 1 or 2 weeks after that. And in parallel, let's start thinking about what next competition to spend our time on as well. Okay, great everybody. Thanks for joining. Appreciate your time.
Cheers. Thanks for that.
See you all 2 weeks from now. Bye.
Cheers.
Thank you. Bye-bye.